So this is the start to my ocean acidification lab. So I have my 5 cups, and then for my acidic liquids, I have apple cider vinegar, Sprite, like soda Sprite, water, just regular water, baking soda here, and these are the bases. So baking soda is the first base, and then isopropyl alcohol. So since I have those in there, I'm just going to go ahead and add a teaspoon of the pH indicator that I made with the cabbage, which is very purple, which I think is a good thing. So I'm going to add a teaspoon into each of these, and then I'm going to dilute them with water afterwards. So I'll go ahead and start adding my cabbage water, aka indicator. Probably need a little bit more than that. I don't have an actual teaspoon, so I'm just using, a little spoon, which I didn't realize I didn't have any teaspoons. So just keep adding these. I can already see them starting to change color. I'm sort of expecting the water to just like stay purple. I'm not really expecting much to come of that, honestly. And my hypothesis for these is that they'll turn really dark. Like, I can already see that on the more acidic side of things, they're sort of turning like a light pink, but I think the basic liquids are going to turn like blue or green. Okay. So I'm going to go ahead and add half a cup of water to each one. So I have my measuring cup. And then I kind of had to just use these. So add a half a cup of water to dilute them. Okay. So 1 moment. Okay. Okay, so I think I'm going to add a little bit more of the indicator to these two, which are my baking soda and my isopropyl alcohol. I sort of feel like maybe they didn't get enough, and maybe my water as well. I guess I still need to stir them too, so that could help. So I'm going to go ahead and give those a stir. The more basic ones look like they're doing what they're supposed to be doing. Or, sorry, my more acidic ones. Yeah, so far my basic liquids are turning like, I hypothesized like blue and green, and they're looking super blue. So there those go. This is just a cup of water. Okay, so now that I have those in there, I'm just gonna go ahead and take a second to explain what ocean acidification is in my own words. So ocean acidification occurs when carbon dioxide rises into the air, which lately has been caused a lot by like cutting down trees and forests, because a majority of like carbon dioxide is processed through photosynthesis. So like the way that I understand it is that plants are holding and trees are holding a lot of carbon dioxide. So when we cut them down at the rate that we are, they're just like exploding out carbon dioxide into the air at a rate that's much quicker than they contained it. So it's like I want to say like 1,000 years, but that might be way too few. But I'll say 1,000 years of intaking carbon dioxide that's just been released out into the atmosphere in the last like 50 to 100. So that's why we have so much carbon dioxide that's raising the air. One of the many reasons, other than general burning of fossil fuels, which are both caused by man. I can't really think of a reason for carbon dioxide to be released out into the air without it being caused by man. I could be wrong about that. So the carbon dioxide rises into the air, and the ocean is able to absorb a lot of that for us, which is problematic. But I was surprised to find out that people used to think that it wasn't, that the ocean could handle a lot more than it can without repercussion. But, anyways, it gets absorbed into the ocean. However, when carbon dioxide reacts with water, it creates carbonic acid, which already doesn't sound good. And carbonic acid creates hydrogen ions. And so, the more hydrogen ions that there are in the ocean, it makes sense intuitively, I guess, that the more acidic the ocean would become. I'm not really sure, like, how long that would take to become truly harmful, but I'll get to the effect in a moment. So the more acidic the ocean becomes, the more the CO2 increases within the ocean, um, and the ocean water gets more acidic. So ultimately, the ocean acidification is the ocean getting more acidic through carbon dioxide being released into the air and absorbed by the ocean, turned into hydrogen ions, and then creating the CO2 in the ocean increases. So the effect of that is that over time, the average pH of the ocean will get more acidic, as said before, and and that will happen in small increments of time. Um, it sort of seems like, from my lens, that even though it happens over, like, I guess it seems through my lens that not a lot of change occurs as like little teeny increments of the average pH of the ocean become more acidic. Like, it seems like it'll take a while for us to notice really drastic outcomes from that. But what can happen is it can cause problems for the sea life in the ocean, specifically pteropods, who depend on skulls and exoskeletons, which it makes sense because the dissolved calcium and carbonate, which creates their skeletons and shells, uh, it yeah, it causes a loss of that. So it's like too much energy to produce their exoskeletons and shells. And the issue with that is it can cause a problem in the food chain. Like, pretty much any other climate change like effect that I've seen on land or water is like the effect of the ecosystem that can eventually affect us. So I sort of see it more of an issue as like regulating um, the the ocean life that's like near the surface of the ocean. So like sharks and whales and dolphins, sea lions, animals like that. Um, I mean, I know in our video it was saying that that causes a problem for like our economy, but I don't know. I just feel like once those animals, like if we got to a point where the ocean acidification was really bad and the sea life near the top of the ocean, near the surface of the ocean, really started to be negatively affected, that would be like a really daunting, scary thing to see and realize. I think that that would be like a make or break moment for humanity in terms of like what we're going to do about climate change, because the second we start seeing beached whales and beached sharks, and I mean at an alarming rate, like that would be truly terrifying and really sad. to see that we as humans cause that. So yes, I am afraid of ocean acidification, not necessarily for my lifetime, but for the futures, like for future generations. Like I could see in the year 2100 that being like a really bad problem, just based off of the timeline that the video showed us. Because I think it said in 2094 it would drop an average of like zero point 0.2 average pH. So obviously over time that would cause problems and accumulate. So it would be in a further generation, but it, as a human on Earth, that's still concerning, even if I won't, even if none of us will be around for that. But so one moment while I just adjust this. Let's see here. So I'm just gonna bring this back over to my cups and show the results of my samples. So I just need to see, let me move this up. There's some questions down here that I need to be able to see. Okay. So here's my cups. The acidic ones did turn, like the most acidic, I have vinegar here. It turned like almost like a peach color, like, I don't know, maybe kind of copper. And then my Sprite turned like light pink, which this makes me feel good because it sort of like an indicator that I probably lined these up correctly. I sort of guessed on which ones were the most acidic to most basic, but it seems like I got it pretty correctly. The water is just like a really pretty blue, just a light blue. Baking soda is also blue, just like a slightly different shade. And then my isopropyl alcohol is just like a deeper blue, like deeper coral blue. So I think that what's happening here between them probably has to do with the the ions associated with our pH indicator reacting with the pH levels of the different liquids. So that is my project. Thanks.